All right, we've got another example of a problem involving analysis of a function. I know I'm covering up part of the question, but it's asking us which of the following is true. Now, this is interesting because they already give us the derivative. Okay, so be real careful there. We know that relative maximums and minimums occur potentially at places where the derivative is equal to zero. So I'm going to take this derivative and set it equal to zero and figure out where that kind of thing happens. And I don't have to take a derivative because they gave me the derivative. By the way, x squared minus 4 factors, I'm going to go ahead and factor that because I need to figure out when this is equal to zero. And notice they tell us that g of x is always negative for all values. Okay, so if g of x is always negative, that means it's never going to give us a value of zero. So the zero values are just going to be coming from these two things, which would be happening at 2 and negative 2. So those are going to be my critical values for my function, 2 and negative 2. So I'm going to make a number line here, and I'm going to substitute this all into my number line, and let's see what we've got going on here. So in my number line, I've got x, I've got the function here, f prime, and we're looking at what happens around 2 and negative 2. So if I put something like negative 3 into this function, and again, you may want to go back to the factored version of the function. Sometimes it's a little bit easier to tell. But if I put something like negative 3 into here, because I'm really trying to tell if the derivative is positive or negative. If I put negative 3 into this function, if I put negative 3 in, the first term would be negative. The second term would be negative. And we know the last term is negative. Negative times a negative is a negative. So f prime would be negative. Function f is decreasing all the way up to negative 2. Okay. Meanwhile, if I substitute in something like 0, which is between negative 2 and 2, 0 plus 2 would give me a positive. 0 minus 2 would give me a negative, and g of x is always negative. So a negative times a positive would give me a positive f prime, and that means the function's going to be increasing there. And then I can put in something like 3 that's to the right of 2, and let's see, 3 plus 2 is going to be positive, 3 minus 2 is also going to be positive, and then g is always negative. Positive times a negative is going to be a negative, and my function's decreasing, okay? Now you should be able to look here and see what's happening. We've got a function that is decreasing and then increasing. That would be a relative minimum at negative 2. I think that's going to be our choice there in D. So remember, if f prime changes from negative to positive, you have a relative minimum. Notice here at 2, f prime changes from positive to negative, and so that is going to be a relative maximum. And so it looks like we have a relative minimum at negative 2. It looks like we have a relative maximum at 2. Actually, I was looking at choice D there. Looks like that's going to be choice B. Okay. Again, if you're trying to justify this on a free response question, if f prime changes from negative to positive, you have a relative minimum. If f prime changes from positive to negative, you have a relative maximum. Okay, so pretty nice problem there. Looked like it was going to be tricky, but actually relatively quick in the grand scheme of things. Could definitely see this showing up in an FRQ.